in probability equally likely outcomes. That means now I am rolling a die. Okay, how many sides it has? Totally 6 sides. So from totally 6 sides, I am rolling a die. Okay, this is a random experiment. So the top part, I am considering about the top part. It can be a 1. Okay, we can't rely on definitely it would be 1. 1 can be an option. Okay, otherwise it might be 2 also. Okay, if not, it can be 3 also. 4 also can be on the top, or else 5. That is also suitable. And 6, this is also suitable. Okay, because all has the equally likely outcomes, because this is an unbased die. That means there is no any imperfection in the corner, there is no any rugged surface. Okay, all are smooth and edges are perfect. In this case, while you are rolling a die, it would be a random experiment. We can't rely on the outcome, but amongst these 6 we can obtain one of the outcome. So these kind of experiments are called as equally likely outcomes. In this case, to write the probability, okay, while my expectation is to obtain number 4 on the top. Think about it, my expectation is to obtain 4 on the top, but there is no any there is no any necessity to that one will happen only. Okay, that won't there are several other possibilities also. No, it can be 1, 2, 3, 4, 5, 6. My expectation is to obtain number 4 on the top. So probability to obtain number 4, to write any probability, first of all you have to write all the number of elements in the sample space. That means totally how many outcomes are there? Totally 1, 2, 3, 4, 5, 6. Amongst these 6, how many outcomes I am expecting? Don't write it as 4. Okay, the how many outcomes I am expecting is just 1. No, just 1. So this is an equally likely outcome, because all has the equal possibility to become as an outcome. Or else, otherwise, just think about it. My expectation is to obtain number 6 on the top. How many? There are totally 6 outcomes. Amongst that, only one time is 6 here. So the probability would be 1. 1 by 6. That is the probability to obtain number 6. This is an equally likely outcome. Otherwise, think about it. Here I have 1 and the top bottom 6. Here 4, 3, 2 and 5 in this one. In here, this edge is little bit broken. Okay, this edge is little bit broken and this surface is not smooth. So we can't expect this equally likely outcomes in that case, because there is a bias. No, this is called as biased die. Okay, so bias. Okay, in the previous case, that is the all surfaces are smooth. No, unbased die. That means there is no any base. Base means some kind of alteration or uncertainty, something like that. This is a based die. Okay, biased die. In this case, this one is broken. This edge is broken. This surface is little bit rugged. So we can't expect equally likely outcome here. There is a partiality towards this 1 and this 4. No, so here we can't expect those kind of outcomes. In the experiments with unbased die or else unbased coin, likewise in those events only we can expect equally likely outcomes. If something is broken, the probability is not equal. No, there is some partiality between this side and this side. This side is smooth, this is little bit rugged. This one is okay smooth and this is little bit broken or damaged. So these are based experiments. In probability, we are not considering about based experiment. We are only considering about unbased experiment. If the probability is uncertain, we can't enter that one into our mathematical calculation. So it has to be a certain outcome. So if this is a smooth die, we can expect 6 outcomes. Amongst that 6, to obtain number 4, the probability would be 1. From 6 outcomes, 1 outcome is having number 4. Same for the second case. To obtain number 6 on the top, totally there are 6 outcomes. Amongst that 6, number 6, to obtain number 6, only one number 6 is there. No? So 1 would be the probability. 1 by 6. I'll use one more example. The coin. Okay. In the coin, we have heads and tails. Heads and tails. While just tossing a coin, how many total outcomes can be either heads or else tails. So to write the probability, okay, probability to obtain tails on the top, there are totally 2 outcomes. Amongst that 2, how many tails are there? Only a single tail. Okay. Then probability to obtain heads, this is also same. Totally 2 outcomes. Amongst those 2, only one head is there. So if you write several times for here also, okay, probability to obtain number 1. Okay, 1 by 6. Probability to obtain number 2. Simple evens are in our concern. Simple even means only one outcome. Probability to obtain number 2. Okay, 1 by 6. Probability to obtain number 5. 1 by 6. All the outcomes has equal probability. Those are called as equally likely outcomes. In this case also you can see probability to obtain tail, probability to obtain heads, both are same. No? So this is an equally likely outcome experiment. Here also this is an equally likely outcome experiment. Here we have to use unbased, okay, unbased tools such as unbased smooth coin or smooth die. Okay, otherwise you are using a tetragonal die. All surfaces should be smooth and the edges has to be perfect. If not, we can't expect equally likely outcomes. That's all about equally likely outcomes. And one more thing I'll recall from our previous grade. To find the probability of an event, you have to identify how many total outcomes are there. How many total outcomes are there? Total outcomes over expected outcomes. How many number of outcomes in the total and how many expected outcomes. The fraction between those two will give you the respective probability.